What is design? You're a fledgling engineer, new to the whole wonderful world of structural integrity and design. Your education has prepared you to approach problems with efficiency and insight, and today is your first day in the design room. It's gonna be a challenge, but you think you got a handle on it. When it comes to design, you know the basic principles. 1. Assess the problem. 2. Identify solutions to the problem. And 3. Implement said solution and profit. The boss hands you your first assignment. He wants you to create a preliminary design for a bridge. Your goal isn't to provide a final solution, but to at least start groundwork and give some good information to the senior engineers who will handle the final design. Looking at the gap, you begin with the basics. You calculate the distance the main bridge needs to span. You identify potential places to apply support. You research materials that would be good for the area and cost effective. You're feeling confident about putting together an initial design. You get into your new design software and start sketching out a design. You start by outlining the bulk of the bridge to cross the gap, and then you start adding structural supports and using that engineer's intuition to flesh out your very first bridge. Your implementation phase involves a senior engineer taking a look at your design. He simulates various cars driving across at different intervals. He nods approvingly, but he has one more test he wants to look at. He toggles a setting you've never seen before called wind, and suddenly you see your virtual bridge collapse. He smiles before asking you how many design cycles you took before submitting it to him. He talks about how design isn't a single linear process. Design, he says, is an iterative looping process. There are variables you'll inevitably miss on your first pass, and your second pass, and your first pass, and so on. And he's right. The variable of wind is something that other engineers had to figure out how to account for. Most famously, the Tacoma Narrows Bridge didn't properly plan for wind causing oscillations, which ultimately led to its collapse. You think to yourself that this design process isn't as simple as you thought, although it does make sense. Rather than thinking about testing as a separate step that occurs after implementation, it's good to reframe the thought process so that the potential solutions are tested beforehand. You think about the work that went into many an engineering project. Building a bridge isn't so fundamentally different from building a rocket, new medical devices, or even computers. It takes careful planning to get these complicated devices to function as you'd hope. Before you can ponder the topic any further, though, your boss sends you your next project. You open the email and begin to work.